In this video, we're going to talk about a way to create continuity. So we may have a function with a discontinuity, and we're going to look at a way that we can create a point that we can plug the hole up with. So let's do an example. So here we want to define some value h of 2 in a way that we can extend the domain of h of t equals the quantity t squared plus 3t minus 10 divided by the quantity t minus 2 so that it's continuous at t equals 2. Essentially, we just want to say what value do we need to make as part of this function so that we can fill in the hole. And right now, I know if I were to plug 2 in, I would get 0 in the denominator. So what we'll look at is we'll look at factoring and seeing if we can determine if that's a hole. In this situation, the numerator factors to t plus 5 t minus 2, and that would be over t minus 2. What we can see here is that we can divide out those t minus 2's. Those are common factors that cancel, and the function reduces to just t plus 5. So at this point, we could say, well, there's a hole at t equals 2. And what would we need to plug that hole up with in order to make this function continuous, not have a hole? So h of 2, if I plug that in, I would get 2 plus 5. H of 2 would need to equal 7. So in order for this function to be continuous, at h of 2, at t equals 2, we would need a y value of 7. So continuing along with a second example, for what value of a? So we're looking for some a value. See a in our function here. Is this piecewise function, f of x, equals x squared minus 1 for any x that is less than 3, or 2ax for any x value that's greater than or equal to 3. So we need to find a number to plug in for a that's going to make this a true statement. So let's look at what we know. We're dealing with here x squared minus 1, and that's for any x value that's less than 3. So if we think about this graph, that's a parabola shifted down 1 unit. So if we were to graph this parabola, it would look something like this, and right over here we would have an end point, and that should actually be an open circle at 3, 8. If I were to plug 3 into that function, I would get out 8. Right? We've got a y-intercept. That's not really relevant, but 0, negative 1, I'll throw that there. So the top piece of the function gives me this left part of a parabola. We're missing some of the right part. So if we want to figure out how to make this continuous for any value, for any x value that's greater than or equal to 3, well, what we need is we need to figure out how I can plug that hole up and make this a straight line. Now, if we look at this line right here, this is going to be the line y equals 2ax. So this is linear, and 2a represents the slope. So I need to figure out what my slope is right at this point where I want to plug up that hole and make it continuous. So we know we're going to use that x value of 3. So this is the same as saying y equals 2a times 3, or y equals 6a. And we know when x equals 3, we want that ordered pair to be 8. So we could say 8 needs to equal 6a. And then I can simplify this, dividing by 6 on both sides. I would determine that 4/3 is a. So a, if I let a equal 4/3, I can plug that in to my function, and this would become continuous, a parabola, until we reach x equals 3, and then at 3 it would turn into this line with a slope, and that slope, that would be like saying y equals 2 times 4/3 x, or 8/3. So this is a line, this line we're dealing with here is y equals 8/3 x, and if that was 8/3 x, that would fill this in and make this a continuous function.